Hey, everybody, welcome to this week's episode of Machine Shop Growth Podcast. I am now your host of this podcast as Mike has um, moved more into the M&A space. He's launching a new show this month, in July, Manufacturing M&A podcast, where he'll be covering some more topics regarding, directly related to machine shop acquisitions and uh, prepping your business for exit and all those different sort of things, sort of at the higher level executive here. So we're going to continue with the Machine Shop Growth Podcast, where we're going to focus on what do you need to do to actually grow within your machine shop. Um, Same things we've been talking about before: top line, bottom line, people. So we'll get a little bit more into the sales side of things in this show, but mostly we're going to stick to ops because growth definitely happens by sales, right? Like if you want to grow your revenue, you got to grow your sales. But, like I said before, sales is kind of it puts things in the door. Your ops determines whether you make money on it. Um, there's things you can do in sales to ensure you make money. Of course, quoting the thing correctly, getting the right type of work, the right type of customers, all the things we've talked about before. But your ops is where, it's no longer all pie in the sky. It's no longer hopes and dreams. This is reality, and you're going to make a part profitable or you're not. And so that's kind of the outline of the framework of how this will kind of work moving forward. So yeah, so we'll get going here on today's episode. Today I wanted to kind of talk about AS9100. There's a big trend kind of running along the AS9100 cert, aerospace and defense type work and all those sort of things. And where do you even start? There's a lot of people that kind of look at the certification as a piece of paper, just a box to check. Like, oh, I just got to get this thing so I can start making aerospace parts. And that's a very dangerous way to think about it. And I say that because AS9100 is more of a culture. I'll call it a lifestyle. Um, it's everything you do has to be according to that in order to have a successful aerospace shop. I mean, you could just check the box and you could be like, countless shops I've been in. Oh, shoot, we have an audit next month. And then everybody scrambles for 30 days, make sure all their T's are crossed, their I's are dotted, all those kind of things, make sure all their documentation's in place. Well, that's because you don't live it. You don't even embrace that AS9100 culture. And now with a lot of the different DoD requirements of CMMC2 and all those kind of things like that, it's even more imperative. ITAR, another um, crucial component of AS9100. Like gonna if you're gonna get AS9100, you're like, I'm not gonna get ITAR. Well, there's no point because almost everything from the AS9100 world is subject to some sort of ITAR regulation. Even you look at these companies that are making rockets and satellites and all that. Well, they still don't want these things ended up in the wrong people's hands. So there's all sorts of ITAR regulation even regarding the most simple components in aerospace. Okay, so let's just kind of think about this. Maybe you're a machine shop, been around for a while, and you're looking to, you know, take that next step in your machine shop. Maybe you're starting your shop in your garage, or you're thinking about starting a shop, and you're like, I want to go the aerospace route. I think there's a few things you should think about and consider before, because just getting the certification alone is a small fraction of the cost of the requirement of everything else. I mean, you could probably go and ChatGPT and have ChatGPT almost write you an entire quality manual. Not, the quality manual isn't a huge deal. It's gotta follow it, right? So training is a massive part of AS9100. Now, I would argue to some degree, if you're starting a shop and it's just you, maybe it's one other person, it's probably the easiest point. to get certified in AS9100 because you have to control the least amount of areas, responsibilities, personnel, all those kind of things. You have to make sure less people are doing what they're supposed to be doing, and you have to get less people on board. Now, I say that, but at the same time, it would be very difficult because maybe you have somebody that, you have one other employee, maybe you have two, and maybe if one of them kind of bucks the system, you have 50% of your workforce, it's, you know, not or is resistant to change, not accepting of that change. So there's pros and cons of both ways, right? So I think the first piece you have to look at is um, budgeting. And where that really comes into effect is your biggest issue, aside from the audit, the ITAR, and all those kind of things, is your gauging. Um, that can carry a massive expense if you're not set up in a manner that you have a full complement of calibrated gauges. You need to have a room that you can climate control, 70 degrees plus or minus two. Um, those things are a cost, right? Especially like think about if you're running the shop out of your garage or something like that. Well, somewhere in there has to be partitioned off and climate controlled. Um, and if you don't have that, that's something you have to add, right? Now, there are ways where you can meet AS9100 standards without having a full CMM. Because of course, that's a major expense, right? Even to go out and buy a used CMM for inspection, probably talking 15 to $20,000. And there's some options out there. Especially with I'm not going to call it Vision, but um, Zoller and some of these other companies made the like the gun type inspection hardware that you can move around with your hands and things like that and inspect parts. It didn't used to be very good on the tolerancing, but it's gotten better over the years. It's gotten a lot more accurate. There's those guns, there's the Ferro arm, the Romer arm, those kind of things. But going back to the I don't even think it's Zoller because Zoller does tool settings. I can't remember. Oh, Keyence made um their other inspection things that I've looked at before, and several years ago, they were their volumetric accuracy as you got bigger, of course, the accuracy got worse. And even in a smaller space, they were good, plus or minus one or two thousandths. Well, it's not good enough for what we do, right? But they've improved a ton. And so they become a more viable option where you can get something for a much smaller price tag where you can inspect a lot more parts to where you're not constrained to just this like 12-inch cube or whatever. Um, Fowler has made a ZCAT CMM fully programmable for years. It's a great option, but still, I mean, geez, the last I looked at those are probably in the $30,000 range. So not cheap to get into that CMM world if you're not already there. So that's a major cost you have to consider. Now, the more budget-friendly option of this would be measuring with manual gauging. There's absolutely nothing wrong with manual gauging. In fact, there's nothing in any um, QMS requirement that says you have to inspect with a CMM. You don't. A little more time consuming in some instances. Some instances it's not. Sometimes, maybe you're just making a couple pins or something like that, and you got to mic a couple diameters and measure an overall length. Big deal, right? I'd rather do that than put it on a CMM because it's a waste of time to put it on a CMM. A CMM will print you out this nice report and everything like that, and it'll do all the things that look good, but you can make that report. Okay. There's also options out there. Level 3 software is one I used several years ago that, will generate your bubble sheets, your AS9102 Form 3, first article inspection report, all those different things. And then you just kind of, fill it out. Looks very professional, looks good. Create you a whole data package that you need to submit to your customer with your first article or with your production parts, whichever the case may be. Um, so, and it's relatively inexpensive. I think it was somewhere $3,500 for the year or something like that. And um, bubble sheets are critical. You definitely want to have those. So, the budgeting for AS9100 is crucial because this is a lot more complex than just, oh, I have a piece of paper. I can go do whatever I want now. Not that case, right? Like, you know, in, in the commercial world, you know, we've all done it. We've all made these parts. We've all worked in that space, or the majority of us have. You got a half 13 tapped hole. Either my tap or a bolt is my thread gauge, and that's good enough. The bolt goes, it's good. Not here, right? Like you have to have calibrated thread gauges, and you have to inspect those holes with that thread gauge. Half 13 or I'm sorry, half 13 thread gauge might run you a couple $100 with certs, right? And that's the key, right? Everything you have has to be certified. You can't just have a thread gauge sitting on your shelf and be like, that's a thread gauge. Nope. It has to be calibrated. Everything that is used for final inspection, first article inspection, has to be calibrated. Calibration also carries cost, right? Now, there's some things you can calibrate internally, using, gauge blocks. There's different like trees and things like that you can get to calibrate mics, calipers, those kind of things. That's, you can cut some costs there. However, when you buy calibration grade gauging, it's expensive. Okay. So, all this is to say here, you have to think about it as a whole picture when you're going to get this cert, because the cert is useless if you don't have the proper hardware to maintain the cert, the proper hardware to maintain production through the cert, right? Okay, so let's just say maybe you don't have all that. There's another option, and that would be third-party inspection. This is also very expensive. Now, if you're a smaller shop starting out, you may have it in your overhead structure to build in a third-party inspection into your price that you sell to your customer. That's an option. Um, but it's not ideal. And the reason I say that is because now you're dependent on a third party who is not tied into your cost structure, your delivery schedule, your anything. You're at their mercy. So if they get backed up and they get busy and maybe they delay your parts a week, well, guess what? That delays your parts a week to your customer. That's a problem, right? I would say the safest bet is to keep as many things under in your control that you possibly can. And I mean that's with just about anything in this world. The more risk you can mitigate from external factors, the better, right? You want to be in the driver's seat as much as possible. Okay, so gauging is a huge expense, and it's an overlooked expense. It, anybody that's done job shop type work in the aerospace world knows, guess what? There's a quarter 20 thread gauge. Okay. I need a thread gauge for quarter 21B, 2B, 3B, an STI. You know, maybe you gotta have, for an external thread, maybe you've got to have a J thread gauge. There's those factors. And I'm not saying you have to have that right at the gate, but you just have to assume and understand those are the things that are going to come your way. It's not like we're just drop a quarter 20 hole in there. They're going to be different classes of fits. They're going to be for hill coils. You may have threads for key inserts, and all these different factors. You've got to have something there to inspect it. That is certified and calibrated. Okay, so moving through that kind of gauging function. Again, you can do a lot of manual inspection. I've worked in several shops that we didn't have a CMM at all. We manual inspected everything we had. Now that was several years ago where, like I said, prices and accuracies and all those kind of things have really come into more of an area where it's more achievable for more of the small shop market. Am I advocating against the CMM? Absolutely not. There's no other way I'd rather inspect a part, especially because when you look at an airplane, you look at a rocket, how many straight edges do you see on any of those structures? None. Just about everything you machine or make is going to be dwarfed, curved, bent, whatever. It's very difficult to measure a profile without a CMM. It can be done, just time consuming, right? Like you gotta go and pick predetermined points and things like that, and hit them with an indicator, a height gauge, or whatever, and it's difficult, time consuming. Where I can just drop a model into a CMM and I can go inspect a profile based on CAD data. So not advocating against the CMM, just saying, these are things that you need to consider pre-audit, we'll say. But even before even pre-audit, when you're starting to go down this road or when you're thinking about it, this is one of the biggest areas you need to put in your mind is how are we going to check these parts? And so with that is what parts are you going to make? Like what parts are you going to target? And I think those things depend on a few different factors. First factor, again, biggest cost, your machines. What machines do you have? Are you capable of effectively and efficiently machining the types of material you want to go after? Do you have the experience you need to go after those parts? You know, do you have smaller light duty machines and you're thinking you want to go after titanium or Inconel? Can you do it? Sure. But are you going to be good at it? Probably not. You're going to constantly struggle against the limitations of your machines. Um, you know, and again, I'm not saying that you can't do it, right? Like I've machined titanium. I've done some crazy stuff on little 40 taper machines, old 40 taper machines. Done it on a Haas, 718 Inconel. It can be done. It's not a big deal. But I certainly hit limitations of that machine where, the same part, if I was running on a big 50 taper Kuma horizontal or something, I could get away with a lot more. You've got to you've got to do things very, very precise when you're getting into some of that tougher metal on lighter duty machines because there's a lot less forgiveness. I mean, there's inherently little forgiveness in that type of material. And then you add the machine on top of it, it's even less. So again, it's not to say you can't do it. It's to say you got to think about this a little bit more um, in how you strategize going after these jobs. Now, maybe you have some lighter duty machines. Maybe they're all paid for. Maybe your overhead structure is a little bit less, so you can build some of that inefficiency into your price. I think you should. I mean, you have to, right? Because you're not going to run a part at the same rate in a 20-year-old VF2 as you could in a brand new, we'll use the Akuma horizontal again, 50 taper. Not going to run as fast. I mean, you could take the same exact program. The Akuma is going to outperform the Haas because it just moves faster. The kinematics are in a way that cycle will run faster in that Akuma than it would the Haas. Period. And then you can also optimize that program, take bigger depth of cut, axial, radial, whatever. It's going to run faster. And now, is it a wash? Because the cost to operate that Akuma is higher, the cost to own that Akuma is higher, all those different kind of things. The tooling cost is higher because a 50 taper tool holder costs more than a 40 taper tool holder. So does it balance out? Maybe. But I think where it doesn't balance out is the lack of predictability or the decreased predictability, right? Um, my tooling cost is going to generally be lower on a horizontal because I'm getting better rigidity, getting less vibration, all those kind of things. I'm going to wear less tools out. And at the same time, I'm probably because of that, I'm going to probably break less tools, right? So if you're running a cycle and you're just burning tools up, and now I've got to change all these tools at the end of a program, or maybe one breaks mid-cycle and then breaks a subsequent tool because you don't have tool breakage detection enabled on your machine or whatever the case is, that cost starts to pile up, right? And if in a vacuum, in a perfect world, yeah, maybe you can run your 40 taper Haas at the same rate, rate per hour, or yes, rate per hour with inefficiency calculated in as you would the Sakuma horizontal at a higher efficiency rating. But we don't live in a vacuum. We don't live in a perfect world. Things are going to happen and it's going to cost you more money. I mean, I've done it, right? So there's advantages to keeping your costs low, but again, are you going after the right parts of what you have? Um, Staying on that same topic, your tool holding, or your tooling, your tool holding, things like that. Are you tooled up for this? Because tooling is expensive. When you start looking at what did you do, what have you done as a commercial shop? What if you're a shop starting out and you've done effectively minimal work? Well, now you've got to get some different tools to go in there and run these parts. So, now you have another huge expense. If you're primarily an aluminum shop and a titanium part walks through the door, you, you've got nothing. I mean, nothing. Um, an Inconel part walks through, again, you're starting at zero. Um, so that's another big expense that you have to consider. So the roadmap to me, if you're going AS9100, is continue doing the things you're already doing and you're already good at. Lay the path, lay the road, foundation, whatever, to expand on those capabilities by the revenue you earn with the current capabilities. Don't try to go into AS9100 and in the commercial world, we're quoting everything that comes through the door. Margins are low. We want to get everything possible. You cannot do that here. You can't. You can't go into aerospace and just say, I'm just going to quote everything that comes in the door. We're going to figure it out because you're good. I mean, you can, don't get me wrong, but it's tough. It is hard because we're not talking about square blocks with holes in each side or whatever. We're talking about obscure angles, very tight tolerances, all those different type of things, generally. Now, there are instances where, yes, you can get the same exact type of parts you're used to in the commercial world, but the reason people want to go to AS9100 is for increased revenue, for increased margin, all those kind of things. You're not getting that on square parts with round or with tapped holes in it. It's just not happening, right? Um, those are, the shops that can do those are a dime a dozen. And so if you're going to go this route, make it valuable, right? Become good at something, become the best at something, become something that nobody else can compete with. I worked in a AS9100 shop out in Washington, and I'll tell you what, we cut titanium and Inconel like it was aluminum. Not at the same speeds, of course, but we had the process, the speeds and feeds, the manufacturing flow, and everything else so dialed in that it was as predictable as aluminum. Um, you know, we had a certain core set of tools we worked with. We knew exactly how they functioned with certain tool holders and things like that. That when they would go in the machine, we knew exactly what was going to happen every single time. So while it took longer to run, it was as predictable as cutting aluminum to us. And that's very important. You have to get very good at what you do because, while there's this illusion to AS9100 and aerospace parts that, there's these fortunes to be made, there's also huge risk. Um, I think I've mentioned this before that there was a part I made, geez, this was eight, almost 8 years ago, and the one block of titanium was $20,000. And there's four parts, right? So we're talking almost 100 grand in titanium. I don't even want to think about how much it would cost today. You're probably just, 120 plus for all that material. So when you start talking about scrapping that kind of money, that is a huge deal, right? In fact, those pieces they couldn't even sell to us. They had to be bought by the end user and provided to us because of the value, because of the cost. They wouldn't do it, right? And some of these parts in the aerospace world are 3D printed. I've had parts before where they said, "Hey, we can't scrap these. We spent 4 weeks 3D printing these. We can't start over." You know, um, so those are the kind of things you have to really think about. Is like especially when you go into this world and you start looking at some of these parts, you have to be very, very sure and very confident of what you're doing because mistakes are tenfold as costly as buying a piece of 1045, right? 1018, whatever. Now, keep in mind here, I'm not discouraging or disparaging commercial world. I know there's a lot of places out there you can make a lot of money. You can get into all these different exotic alloys, right? You can get titanium parts. You can get into some nickel alloys, different exotic stainlesses and things like that. So 17.4, 15.5. Nitronic 60, you can get into some of that stuff in the commercial world. It's just not as prevalent. Aerospace world, it is. You're gonna see cold rolled steel as frequently as you're gonna in the aerospace world as you would see 718 Inconel in the commercial world. I mean, that's where it's a little bit different. So, we're looking at our quality. What's it going to cost to get our inspection department up to snuff to make these parts, inspect them, certify them, ship them, all those kind of things. We're looking at our machines. We're looking at our tooling, things like that. Do we have multi-axis machines? Are we going to dovetail and tab parts? What's our workflows going to look like as we're making these parts? Another thing you need to look at, ERP software. Can you manually manage an AS9100 QMS? Yeah, you can. People have done it for years. Anybody says you can't, not true. It can be done. It has been done. It will continue to be done. Is there an easier way to do it? Yep. And that would be through an ERP software. There's several out there that have integrated quality functions where you can store your, quality documentations and things like that. When you go to ship the job, you can print all of your certificates or your certifications, and things like that and ship it with your parts. They exist. They're out there. I would say that they're not required, but yeah, I have a hard time arguing against them. You know, because when you go and you make aerospace parts, everything you do has to be documented. Everything you do that touches that part has to be, you have to spell out what you're doing, right? Down to your machine maintenance. Part of AS9100 is you have to have a daily maintenance log, and then you could define what your other maintenance intervals are, whether it's quarterly, semi-annually, annually, those kind of monthly, those kind of things. You have to have a PM schedule on all of your machines, and you have to actually do it. Why? Those machines touch that part. Anything that touches that part has to be documented, including the process, right? So let's say a part comes in your shop, or material comes in your shop to make an aerospace part. You got to say what you're doing at each step. I mean, and usually when I route parts, it's down to receiving. We conduct receiving inspection. We have to certify that material is what we asked for, is within it meets our criteria, or inspection criteria, acceptance criteria, I should say. Um, it's labeled as the correct material. We have to, record the heat lot, um, store the MTR or the material test report. We have to store the MTR in the appropriate location, identify the material, because that's a huge one, right? If you order extra material for a job, say you need to make 10 parts, you order 12 pieces, and you only need 10. Those other two you can still use on other jobs, but you have to identify that material. So, a lot of the times when the material comes in, I would label it as what's the heat lot, what job number is it going to, part number, etc. And then, after we run the part or whatever, if it becomes stock material, we can, remove the non-applicable data. But what remains is definitely the heat lot material type. Maybe you can leave the PO number on there just so you can go back and look if you ever are in question of like, what is that material? All those kind of things. Okay, so, you know, that's how detailed your routing needs to be, because that is a step that affects that material, right, through the process. Um, so the ERP software helps you a lot in that aspect of makes it very quick to route your steps. And through your routing, what are you actually doing to this part? What's your inspection frequency? Let's just say you're a production shop. You have to define within your work instruction or your job router, how many of these parts are we going to inspect? Are we inspecting every 10? Are we inspecting every 20? Like you have to instruct how we're going to make this part. That's the whole purpose of the router. And those things need to be filled out and detailed. Now you can have kind of a blanket policy and not necessarily have to fill that out for individual instruction. Like, hey, look, this is our policy for this part or that part, or this is our, but it has to be identified somewhere. You can never, anytime an auditor comes in, I'll tell you, I'll give you a little thing I learned a long time ago. Auditors hate seeing blanks. If there's a blank, that's almost always going to be minor finding, no matter what, period. A blank is a problem because a blank is leaving the decision making up to anybody that touches it. Anybody that touches it can decide what they want to do at that point because you've not defined what they should do. So going back to the ERP software, these things help keep that a lot more stabilized, a lot more streamlined, a lot more organized, we'll call it. And quite frankly, from a business perspective, the ERP software is a major asset to anything you do in a machine shop because it helps you keep track of your costs. What are you putting into a job? And the other thing is, you have to store records in AS9100, 10 years. Well, instead of having, filing cabinets upon filing cabinets of paper record, scan them all into a digital repository or the cloud or, whatever the case is. Scan them all in there, and now you have them stored forever, indefinitely. Um, so those are that's another consideration you have to look at. Like, do you have an ERP software, and what's it going to cost you or take you to implement it? Because that's not free either. That takes time, that takes money. The cost of the software per year is negligible compared to what it's going to cost you to get it implemented and stay on top of it, right? People get all bent out of shape. Oh, I don't want to spend that kind of money a year. Come on. You're talking some of these softwares are 10 grand a year or something like that, $1,000 a month or whatever. You save it with the reduced amount of pain you're going to feel, but it does carry another cost of that's one. Now another factor to consider is again, like I said earlier, you want to go do DoD work, you're going to be CMMC2. So any type of software that you put any sensitive information in has to be FedRAMP certified. That's another factor to consider. Like that's going to dictate which softwares you can go with. A lot of the big ones, they're tailored to machine shops. They're already certified or they're in process of getting it. So, it's not like there's no options out there. There's several, right? But just another thing you have to consider. Sticking on the software. What CAM software do you use? You want to be a DoD supplier, can't use Fusion. It's all cloud-based. They're not FedRAMP, right? You need to think about that factor. That's going to add a cost, right? You want to switch. If you're right now, using Fusion at $500 a year, well, now maybe you got to go buy Mastercam at, starting out at 15 grand for a 3-axis mill. That's a cost, right? Now, not everything needs that. You can make plenty of aerospace parts using Fusion. I don't advocate for it. I don't really like Fusion, but for programming anyway, but it's an option. Some people like it. Good on you. I wish I liked it because it's less than a truck payment for a whole year, right? It's cheap. And it does a lot of good things. Don't get me wrong. It's not horrible. Now, you get into some of these more difficult multi-axis parts. I don't know how beneficial Fusion would really be for that, but hey, if that's what you use, that's what you use. I'm not here to bash anybody's CAM software choices. Okay, so softwares are another consideration. You got to think about that. Again, are you going to use some sort of uh, bubble sheet type software? There's some AI tools out there right now that you can drop a drawing in and it'll automatically bubble every feature on there for you. Are you going to use something like that? Are you going to manually do it to start? Those are the kind of things you got to think about. Next thing is going back to what type of work are you going to go after? What type of shop are you? Are you a quick turn shop where, hey, I get a part in here, I got a 1 to 2 week lead time and it's out the door? Are you a production shop? Are you, you know, are you low volume, high mix, or are you high mix, low volume? That's what you got to think about because that's going to dictate what and who you go after, right? If you're a Swiss shop, we'll just say, you're probably not going to go after Blue Origin, SpaceX, those kind of companies because they're not doing enough volume to justify a Swiss. Now there are opportunities there. Don't get me wrong. There are some small fasteners or things like that you could probably get, but you're looking at a very, very, very small segment of their of their need. And a lot of that segment is probably already spoken for. Swiss shops are in lower uh, um, availability. There's not as many out there. I get that. Um, so I'm not saying it's a horrible idea, but just know your opportunities are going to be much more limited, right? Um, same same to say on the other side. Like if you're uh, a low volume, high mix shop and you specialize in quick turnaround, Boeing probably isn't your best option. And I say that because when you are low volume, high mix, you're typically charging a higher rate because your labor is higher. Swiss machines run unattended. And you get the thing set up, you get some bars loaded in there, the thing can run for days with nobody there. Not in a low volume, high mix shop. You've got to have, highly skilled technicians at the machine, in the programming seat and the QA seat, to conduct the inspection and all these functions, working together. And so you're generally going to charge higher rates, higher margins, because you're going to have higher rates of scrap and things like that because you're running so many one-off type parts. Boeing will beat you up. And, a lot of their parts, there's, again, it's not all, right? Boeing still has R&D and those kind of things that they're going to send out from time to time. They're going to have tooling and things like that he made. But the squeeze from Boeing on price is real. Um, they are much, I'll call it, they want much more competitive pricing than some of the other um, space exploration type companies that are also, they're, quite honestly, are looking for more of that rapid turnaround. Because you got to think the commercial air travel market pretty well settled. You know, Boeing, Airbus, those are the big two that are making everything that flies for commercial air travel. The space exploration game is not settled. While you've got the big two, Blue Origin and SpaceX, there's a ton of space exploration startups, and it's not even people building just rockets. It's people building satellites, other space exploration hardware. They all need machine parts, and it's a competition right now. Who can make it the fastest? Because whoever, creates the sustainable system the quickest is going to win these massive contracts and things like that from, primes or other from the government, from whatever. Um, you know, so going after them as a low volume, high mix shop, you're going to have a lot better uh, opportunity from your price structure because they're not going to be as concerned about price because the opportunity value is much, much larger than $100 on a part, an extra $100 on a part. They're just not going to care, right? So those are the type of things you should consider there of what type of shop you are. Now, going a little bit deeper into what type of shop you are, I'm going to go back to that previous point of what kind of parts do you make? Are you a three-axis shop? Do you have any lathes with live tooling? Do you have four-axis shop? Do you have five-axis shop? Do you have horizontals, pallet pools, those kind of things? Because again, that's going to determine what kind of work you want to go get. Um, you know, you do not need a five-axis mill to be an aerospace shop. In fact, I'm willing to bet if you look at shops under 5 million, they're AS9100 certified. I don't want to say percentages, but because statistics are, generally made up anyway. But a large amount of those shops are not going to have a five axis at all. Maybe they have one. You, you see these videos and these people talk about it. It's like, oh my God, you have to be this high tech, sophisticated shop if you want to make aerospace parts. Not true. Not true at all. I've worked in more shops that are aerospace certified that have not had a five axis at all than shops that I've worked in that had a five axis. The truth of the matter is, while five axis is an amazing thing, any programmer will tell you this, or the majority of programmers will tell you this. There are some that maybe they work exclusively in simultaneous five axis machining. There's a few instances where that's necessary, turbine blades, things like that. But Most programmers can count on two hands the number of times that they have generated a simultaneous five-axis machine toolpath because it's just not necessary in most instances. Is it cool? Absolutely. When you see these, I just saw a video of the Integrex machine in the World Cup trophy. Is that awesome? Yeah. But how realistic is that? How many people are ordering that part? Not many, right? Most of your machining is going to be 3+2, 3+1, that kind of thing. You're talking positioning, machining, drilling, whatever. So while there are instances where it is necessary, or maybe it would be just a nice to have, it's not a requirement. I have done more on a four-axis horizontal than I've ever done on a five-axis, and needed the fifth axis. A lot of your parts can be done at four-axis, really, truly, and you can tab them off and not even have a second op. You just do it all in one. Going back to that 80/20 rule, we worry about 80% of what's happening. We don't, the 20%, we're not planning for that specifically. We're planning for the 80%. And the 80% is going to come through your door is fully manageable by four-axis machine. Lathes with live tools. If I'm ordering a lathe in 2026, I'm not ordering anything less than a lathe with live tools y-axis because there's no reason to buy it any other way. You know, yeah, you might save some money here, you know, by not getting that, buying the machine, but you'll make it back so fast by not having those second ops. You can just part the thing off, it's done. So that's kind of the way that I view that. So going back to that question of like, what do you do? What are you good at now? Are you an aluminum shop? Yeah, it's cool. Plenty of aluminum in aerospace. Plenty of it. Stay there. Stay there, get your feet wet, get your feet under you, make some parts, um, and slowly grow into that other world. Because again, like I said, unless you've got some investor capital, institutional money, whatever coming in for this certification, I would not go dump a bunch of cash into something that you don't know if you're good at or not. Can you figure it out? Sure. But it comes at a major risk because some things are very difficult to figure out and they're expensive to figure out. And you got a business to run. You got a business to run, you got bills to pay, you got families to pay, things like that. So it's a little bit of a risk. Maybe you are a stainless shop and you're going to go after stainless. Plenty of stainless in aerospace too. But I think that's one of the big distinctions is start, you got to scale, right? When you come into AS9100, you're starting at zero, effectively. Maybe above zero, because you have machining experience, you have machining knowledge, you have all these things that um you can build from out of the gate, but you have to scale into it. You can't, coming in and just be like, I'm going full bore, taking it all. Very, very risky. Now, it happens, right? Some people do it. The old phrase, you catch lightning in a bottle. Do not base your reality on those. Um, there's a lot of effort, determination, grit, and things like that to go into those stories. Also, a lot of luck. Anybody in business that tells you everything that happened is all because of me, nothing else mattered. Uh, I don't, I don't, I don't believe those stories very much. Um, because I've been around long enough to know that sometimes you're just in the right place at the right time. Sometimes you just got lucky. Those guys are typically the people you see. They're like, follow these 5 steps to become a millionaire. This is how I did it. But those 5 steps don't exist anymore because those 5 steps include talking to the people that you talked to, being at the place you were at the time you were there, doing the things you were doing then to put you in that position. That isn't real anymore. And so, there's some luck associated with it when you see some people that, you know, bite off the whole thing and just go for it. Because I'll tell you, the stories you don't see are the people that lost everything trying that route because there's a lot. Um, you know, I think years ago I read an article with machine shops that something around 75% of machine shops fail in the first year, and 50% of those 25 that succeed fail in the next 4 years. And I fully believe that. It's a tough business to get in because you get all these things I've mentioned already. You know, you want to go this route to, chase these fortunes that exist in the aerospace world. Well, when you don't properly plan, you get bit. You get caught by all these gotchas of you don't have the right gauging, you don't have the right machines, you don't have the right tooling. You're going after jobs you had no business making in the first place. These are all speed bumps that you have to think about before you start going down this AS9100 path. The next one I'll talk about is your personnel. What kind of people do you have? Do you have people that, and I'm not bashing these people at all. Quite frankly, I love these guys because I know exactly where they stand. Do you have guys that when you walk in or girls that are just like, I want to do my job, I just want to go home. I don't want to make decisions. I want to be told what to do. I want you to handle all the rest. You're now putting all this on your shoulders, everything. Or do you have people that are eager to learn, want to try new things, want to do things differently they've done before? They want to embrace the new system. Those are things you have to consider as well. Um, because I'm telling you, in this world, any world of manufacturing, you never know it all. Can't, won't, you don't. I mean, even doing this podcast, there's times where I'm like, man, I don't know anything unique. Anybody that does this could figure this stuff out, because I'm constantly humbled all the time. Stuff that I look at to do, and it's like, oh, no problem. And I get into it, I'm like, oh crap. Well, I didn't think about this. I didn't think about that. Oh shoot. Now how am I going to hold this on the second side? All these different things that you've got to have the mind for that. You've got to have, you want to have people with the mind that are like, we're going to figure this out no matter what, because that's ultimately the most important thing. And I wouldn't even say just in manufacturing, just in everything in life in general, it's just resiliency. When something hits you on the chin, like you got to get back up and you got to just figure it out. You got to keep going and make it happen, right? And so personnel is a huge constraint, a massive constraint. I worked in a shop once that we're aerospace, and man, every single part was a nightmare. I mean, big, expensive material, complex geometries, nasty material, and height tolerance, just every long cycle times. I'm talking like I made some titanium fittings that were over 100 hours. We made a bunch of them that were a 40-hour plus cycle, and we wanted to run unattended. So, you run it at night. Oh, by the way, titanium is extremely flammable. It chips and things like that. So now you're running at night when nobody's there. It's like, holy crap, hope the building doesn't catch on fire. You know, um, if that's the kind of stuff that you got to have the right people for. If you have people that shy away from a challenge, you got to consider that with, when you start thinking about the complexity of the parts you're going to bring in. It's like, do I have the people here that can handle that? If maybe you do, and maybe they're just not at the right point yet. Do I have the people that I can train to be at the point I need them to be for the work I want to bring in here and the work I want us to start doing? Because I mean, your people, your equipment, and your cash are your three bottlenecks in anything to do with manufacturing, no matter what. We've talked about your cash, right? We've talked about these different constraints you have to think about from a quality perspective, tooling perspective, all those kind of things. One of the other one is going to be your material purchasing requirements. We'll get into that in just a second. But now we're on our personnel. Like, do you have the people to do it? Do you understand GD&T? If you don't understand GD&T, you better figure that out like yesterday. Because if you don't understand GD&T and you don't want to understand GD&T, do yourself a favor. Do not go for an AS9100 cert because it's nothing but GD&T. Plus or minus 5 on a linear dimension doesn't exist very often. You're talking about profiles usually, and not all the time. Again, like don't get me wrong, it's not, probably exaggerating that a little bit. There are square blocks. It'll be like plus or minus 30. But there's a lot of profile tolerances, true position. Um, all those different angularity, perpendicularity, run out, total run out, cylindericity. concentricity, all those things. That's what all these things are based on, all of it. So you got to be prepared for that. Do you have somebody in inspection that understands it, that can communicate effectively in GD&T back to your machinists, back to your setup guys, back to your programmers? Do you have a team that works well enough together? Because a lot of these parts are a team effort. It's, again, you get into some of the simpler, more production style parts. Yeah, it's no big deal. But everyone's coming here because they want to make cool stuff, right? You got to have people that can make cool stuff. So that's a major, major, major consideration that I think gets overlooked even more so because it's not one that's like, hey, I'm a business owner. I'm only worried about what it takes to get it from a financial perspective, making sure we have the proper capital allocation, and let's just get it implemented. You got to think about your people too, unless you want to do it all. Um, and even from an owner's perspective, like, are you capable? Are you capable of leading and managing an AS9100 team? Do you have the ability and the humility, quite frankly, to handle the losses? Because you're not going to win every time. I'm telling you, you're not. There's going to be big bills on whoopses. Uh, there's no way around it. I mean, it's with any type of business, not even just with aerospace. I worked at a non-aerospace shop once and watched you guys scrap $10,000 of material because he didn't check the groove width. Those things happen. I mean, it's an imperfect world, right? So the other thing to consider from a financial perspective is your material. When you order material from an AS9100 requirement, usually you're going to have some sort of pre-machine inspection, ultrasonic inspection, something like that, just to make sure there's no subsurface deformities, defects, things like that. You're going to machine it. After machine, you're going to have a die pan inspection, mag particle, something like that. Not always, but generally, these are just things that generalizing here. Um, yeah, some sort of inspection to make sure that, again, there's no microfractures and things like that in the material, because a lot of these things, like the structural integrity, is critical to keep people alive, right? After that, probably going to have some sort of post machine processing treating, um, anodize, chem film, passivate, you know, you name it, going to have something, at least one, sometimes multiple. Okay, so your days of a 4 week lead time, man, you can do it, but you better be moving, right? Especially on bigger orders. A lot of the stuff that we were running before was on a 3 month lead time, 12 weeks, and then you're not getting paid for 60 to 90 days after that. So you could be talking about material you bought today, you're not getting paid for 6 months. That's something you got to think about big time. Line of credit, line of credit, line of credit. Um, some of your material suppliers, maybe you can work out some better terms with them, but you got material you got to pay for. You got to pay for maybe your ultrasonic inspection, pre-machining. That's going to be paid for before you get paid. Your labor, it's got to be paid for before you get paid. Your post-machine inspection and processing, got to be paid for far before you get paid, because you're probably going to be on 30 days. You're going to ship and you're not going to get paid for 30 to 60 days after that payment's due. So talking about a big cash flow crunch. Again, not saying always. There are plenty of things out there you can do aerospace that you can ship in 4 weeks, but these are things that you have to think about because it's very common, right? Very, very prevalent that you know you have to have pre-machine inspection, you have to have post-machine inspection of the material, and some sort of plating or post-process. So your cash flow is very, very important. It's a very important thing to think about when you start going into aerospace because it's different. We QuickTech is a commercial shop, right? We make part that we get a PO. Most of the time, we turn a part over 2 to 4 weeks. I mean, we're pretty quick on a lot of our parts. They don't go to plating. We get paid 2 weeks after our bills due, that kind of thing. If we sometimes we might get paid the same day if we can just flip it out really quick. Material shows up, bam, done. Send it all the same day, right? That is very, very uncommon in the aerospace world. And honestly, a lot of these big aerospace companies, they're not paying a net 30. Probably not paying that 60. Maybe you get 90 days, but you might even get 120, so you're going to have to sit on money for a long time. Now, there's ways around that. It's all in your contract negotiation. Do you require down payment? Do you require progress payments? That kind of thing. But again, you're largely at their mercy. I mean, there's people knocking on their door every single day wanting to make their parts. So there are ways that you can try to work some of that stuff in, but it's not always guaranteed because guess what? That means those buyers have to jump through some hoops for you and things like that. So, you know, going into it, maybe it's an option, maybe it's not. But again, this is the plan for the worst kind of thing. So, um, okay. Yeah, I think we're probably good for today. I think we're coming up on an hour here. So, just going back to kind of go back through really quick, you're a shop thinking about getting AS9100 certified. What are some of the pitfalls you're going to be looking at? What are some of the things that maybe the unknowns, right? Um, well, we talked about your QA cost. We talked about your softwares, your machines and tooling, material, kind of some cash flow constraints. I think I want to do a part two on this because I also want to talk about building your quality manual, your audit, ITAR certification, and then so assuming you want to go down the DoD route, you got to start thinking CMMC um, sooner rather than later. And those are other major factors. Every one of them costs money. Uh, some of them cost a lot more than others. And so we'll get into a little bit of that in the next episode. But other than that, appreciate all you guys listening. If you guys wouldn't mind, leave us a review. Helps, get us out to more people. If you're finding this valuable, surely there's other people out there in the world that could also find value in it. I really appreciate some of the listeners that have reached out to us and given us some constructive feedback, even some that have said, "Hey, I got this issue. Would you guys mind helping me with it?" We love it. We love to help any way we possibly can. It's I know as well as you do as an owner, it's getting harder and harder to find good people, qualified people out there. We've got to constantly do more with less, and that fractional consultant contractor type thing is becoming more and more prevalent because there's just less of us out there. And so I'm more than happy to help out within any problem as best I can. I may not always be the right guy for the job, but I can find somebody to help you. Know enough people that we can get the problem solved. And so yeah, if you guys have those things, have those things you're just stuck on, you want a fresh set of eyes, more than happy to help any way I possibly can. So um, yeah, that's it for this week. Appreciate you guys all listening, and we will talk again in a couple weeks. See ya.